Okay, we're continuing on here with section 10.2, looking at drawing out two samples, one from each of two populations. We ended in the last video constructing confidence intervals for estimating the differences between two population means. Remember, when we're dealing with means, this is when we use t-scores. When we're dealing with proportions, that's when we use z-scores. We use the acronym ZAP-TAX to help us with this. Okay, so we're going to go ahead and see if we can walk through. I've filled in lots of the elements for this confidence interval construction. Here we're talking about for their semester 2 project, we have Ashton and Olivia, and they wanted to know if generic chocolate chip cookies have as many chocolate chips as name brand chocolate chip cookies on average. To investigate, they randomly selected 10 bags of Chips Ahoy cookies and 10 bags of Great Value cookies, and they randomly selected one cookie from each bag. Then they carefully broke apart each cookie and counted the number of chocolate chips in each. Here are the results. And you can see this is the number of chocolate chips found in each cookie that was randomly selected for each of the 10 bags for Chips Ahoy, and then the same for Great Value. We are asked here in this problem to construct and interpret a 99% confidence interval for the difference in the mean number of chocolate chips in Chips Ahoy and Great Value cookies. Okay, this is where we follow our state, plan, do, conclude procedure here. Okay, we're going to start with the state procedure, or the state step, which is where we define our parameters. Okay, these are the mu's, and we state what it is we are estimating. So I have filled in here mu sub CA. This is the true population mean number of chocolate chips in the Chips Ahoy cookies, and the mu sub GV is the true population mean number of chocolate chips in the Great Value cookies. Okay, so that's what our two parameters, these variables, are going to represent. We want to estimate very important, we are estimating the difference in the mean number of chocolate chips in Chips Ahoy versus Great Value cookies. We are going to use a 99% confidence interval, and it is always a good idea to state the order that you're going to be doing your subtracting in. We're going to do the average number of chocolate chips in Chips Ahoy minus the average number in Great Value. Okay, that brings us to the second part to this procedure, which is the plan step. This is where we are listing the conditions, and we're going to name the inference procedure that we will be performing. Okay, our conditions, there are technically 4, but we weave 2 of them together in this first one. We want to make sure that we are stating that the samples were taken randomly and independently of one another. Okay, so we're just assuming that they were taken certainly independent of each other. It does mention up here that they randomly selected one cookie from each bag. Okay, then we need to do the 10% condition. This is where we take 10 times the sample size. Okay, they chose 10 bags of cookies here, and make sure that 100 would be less than or equal to all bags of cookies from each company. I believe the sample size was the same for Great Value and Chips Ahoy, so we only need to show that once. Okay, now we need to do the test for normality to show that this is approximately normal. Now remember, our 3 options are, if they told us in the problem that the population for Chips Ahoy and the population for Great Value was normal, we could just cite that. There was no mention of normality here for the populations. Our second thing is, if the sample sizes are greater than or equal to 30, we could cite the central limit theorem for each sample, but this is 10. So our last option is to take each of the sample data sets that were given and construct some type of a graph. I prefer the box plot. We would type all these values into L1, all the Great Value values into L2. We would construct 2 box plots on our calculator. Now, when you make this on the calculator, you absolutely have to copy the box plots down onto your paper when you're doing this on the AP test. Very important that you're labeling your axis as well. So our x-axis is going to represent the number of chocolate chips. And what I'm going to have over here is I'm going to have two box plots. I'm going to have one drawn for Chips Ahoy and one drawn for Great Value. You should, after putting this data in L1 and L2, go into your stat plot, turn on both plot 1 and plot 2. Make sure plot 1 has to do with L1 and plot 2 has to do with L2. You can then press Zoom 9 for Zoom Stat, and it should show you the sketches for each of these box plots. We're just going to do a rough sketch of each here. Now, if you choose the box plot, you want to choose the type that will definitely show you if there's an outlier, you know, with an extra asterisk or something like that. Okay, so I'm just doing a rough sketch here of each of these box plots. And I can see that on my screen there were no extra indications of any outliers. So I want to make that remark here on the paper. I'm going to say that the shape for the sampling distribution is going to be approximately normal because neither graph shows extreme skewness or outliers. Okay, so we're able to kind of check off that condition as well. Okay, that brings us down to the do step. And in this chapter where we're talking about drawing out two samples, one from each of two proportions, I'm highly advising you to use the calculator feature for this. Okay, oh, I think that I failed to write down, in this plan step, we should be stating the inference procedure that we are using. Okay, this is going to be called a two-sample T, because we always use T-scores instead of Z-scores when we're doing means. And this is this is a confidence interval, so this is a two-sample T interval. Okay. Do take note here, it mentions that when you're doing these two-sample T intervals, we should always be saying no to whether we want the pulled option or not. Okay. Okay, now what you would do on your calculator is you would press the stat button, you would bump over to the test menu, you would find two-sample T interval underneath option 0. You should choose the data option and make sure your inputs are listed there for L1 and L2. We want to switch this, so we are definitely talking about a 99% confidence interval for your input, no to the pooled, and then go on down to calculate, and you want to report all the values that they are giving you there. So they're going to give you the sample mean for L1, which I believe L1 is the Chips Ahoy data. I'm just going to make a note here that this is Chips Ahoy. And then L2 is everything pertaining to Great Value. Okay, so I'm just reporting all these things I'm seeing on my screen here for each of these. Okay, and we also want to definitely make sure that we are reporting the degrees of freedom that the calculator gives us. Okay, the calculator uses a little bit more complex formula for the degrees of freedom, which is fine. Just report whatever it tells you to there. And then obviously we want to definitely be writing down here what our confidence interval, this is where we're estimating where the true difference between these chocolate chips is really located. Okay, somewhere between negative 4.814 and 2.8138 is where the true difference, and I think the order of our subtraction was Chips Ahoy minus Great Value. Okay, that brings us down to the last step. You'll notice over here in this box, I was simply showing you if you were going to do this not using the calculator, how you would use the formula, what it is that you would substitute in here. This procedure I'm doing with inverse T is how I would have gotten this T-score that you're seeing right here, 3.25. You get that by inputting this into your calculator. Again, I wouldn't really advise doing the problem this way, but this is how you would do it if you were going to use the formula and not the calculator feature to sample T int. Okay, our final step in this is our conclude step, where we are going to interpret the confidence interval. We are going to say that we're 99% confident that the interval, then we state our interval, captures the true, here, very important, you have to say that we're capturing the true difference in mean number of chocolate chips in Chips Ahoy and Great Value. Okay, what you'll start to notice here when you're doing confidence intervals is there is a distinction, a link between confidence intervals and the conclusion that if you were to run a significance test on this, that you would be drawing roughly the same conclusion here. So here they're using a phrase that we're used to seeing when we're asked to do a significance test. Does the interval provide convincing evidence that there is a difference in the mean number of chocolate chips between these two cookies? Okay, now remember, if there is a difference, then 0 should not be a plausible value, okay? If there is no difference, then I would expect that 0 should be a plausible value, because if 0 is a possibility in my confidence interval, it means there is a chance that these two means are actually equal to each other, indicating there is no difference. Well, I'm going to respond to this then. Because the interval includes 0, there is not convincing evidence that there is a difference in the mean number of chocolate chips in Chips Ahoy versus Great Value chocolate chip cookies. Okay. Remember, your convincing evidence is always referring to what your alternative hypothesis would have been. The null is always no difference. So the convincing evidence is either, it's always talking about that there is a difference. And since 0 is included, we don't have that convincing evidence saying there is a difference, because there could not be, since we have 0 included here. Okay, let's go ahead and shift to those significance tests. You're going to see this is really just an extension of the significance tests that we learned when we did this with just one sample. We had always called this a one sample t-test. We had used this formula here to calculate the t-score, and the degrees of freedom was always our sample size minus 1. Okay, it does mention here that an observed difference between two sample means could reflect that there's actually a difference in the true parameter means, or it could just be due to that chance variation in random sampling or random assignment. Now, I want you to pay attention here to the distinction between how the formula that you're seeing here is really just an extension of what we have here. I guess I should just mention that this is all talking about if the standard deviation is known. That is the only time that it is a z-score. Okay, or I guess the piece that I want you to connect here is that you'll notice your sample, now we're talking about a difference, so that this is our statistic. Okay, what goes here is the parameter, which is the difference in the means. And then your denominator is the standard deviation of your statistic. And this formula I highlighted down here in blue, that's actually on the formula sheet. Okay. So when we're talking about doing this though with t-scores, and I think more appropriately, it's going to be set equal to t, and it switches to a t-score for the simple fact that now we don't know the population standard deviation, so we're replacing that with just our sample standard deviation. Something that you should note here is this difference in your population means you will always use a 0 here, because our null hypothesis is always going to be assuming that there is no difference between your two population means. If there's no difference, when we subtract them, the difference is 0 then. Okay, there is a very complicated formula for how to calculate the degrees of freedom. You see it listed right here. This is not anything that you will need to calculate. If you're ever going to calculate what the degrees of freedom are going to be by hand, you're just simply going to use a very conservative technique, which is simply to take the smaller of the two. Whichever sample size minus 1 is smaller, that's what you would use as your degrees of freedom. Now, when you use the calculator feature, it uses this more complex formula, and that's why you'll notice the degrees of freedom feels like it's a different number than just doing this here. Okay? The formula is more precise. We are not going to use the formula. Okay, so here essentially is what we're dealing with. The name of this test, now that we're talking about a significance test and not a confidence interval, this is a two-sample, instead of t-int, it's a two-sample t-test. Okay, you'll notice on the calculator, if you press stat and bump over to test, you will see this is listed as option number 4, two-sample t-test. Okay, your hypothesis. The null hypothesis is always a statement of no difference, and the alternative is either greater than, less than, or not equal to 0. Okay, same exact 4 assumptions that we do for two-sample t intervals. Okay, the random, the independent, the normality, and the 10% condition. And then you can see underneath here, this is essentially what the formula is to get the t score. Okay, and here's our shortcut for degrees of freedom. Okay, so we're going to actually pass over the next example here, and we're going to jump to this example for a two-sample t-test, where I have parts of this filled in for you, and this will bring this video here to a close. Okay, the question for this is, does increasing the amount of calcium in our diet reduce our blood pressure? Okay, so it says examination of a large sample of people revealed a relationship between calcium intake and blood pressure. The relationship was strongest for black men. Such observational studies do not establish causation. Okay, if you want to get causation and show that one thing is causing another, you have to have performed an experiment. And what distinguishes an experiment from an observational study is you are randomly assigning treatments. Okay, you're randomly assigning treatments here. Researchers, therefore, designed a randomized comparative experiment. The subjects were 12 healthy black men who volunteered to take part in the experiment. They were randomly assigned to two groups. 10 of the men received a calcium supplement for 12 weeks, while the control group of 11 men received a placebo pill that looked identical. The experiment was double-blind. That means the individuals did not know whether they were receiving a placebo or the calcium supplement. It means the doctor who was measuring what their blood pressure was did not also know which treatment group they were in. When they reported the blood pressure, the statistician, the researcher, was the only one who had the knowledge of who was receiving which treatment. It mentions here that the response variable, be very careful with this, is the decrease in the systolic blood pressure for a subject after 12 weeks. Okay? And so that means an increase in your blood pressure is going to appear as being negative. Okay? So here's the data. You can see that essentially what we're saying here is this first person here who recorded a 7. Okay? What that means, that 7 means, is that that person's blood pressure over 12 weeks showed a decrease in 7 millimeters of mercury. Okay? Their blood pressure decreased. Whereas when you look at, this next value, the -4, that's indicating that for this person, they actually showed an increase. Okay? An increase. Because the way this is defined, it's a little bit tricky, okay? The response variable is the decrease. So it's saying we decreased by 7. If it's a -4, it really means that this person's blood pressure increased by 4 millimeters of mercury across the 12-week span. Okay, now here's the question. Does the data, here's the phrase that tells us we're running a significance test, provide convincing evidence that a calcium supplement reduces blood pressure more than a placebo? Carry out an appropriate test to support your answer. Okay, so we're going to fill in the blanks here. Mu sub C is the true population mean decrease in systolic blood pressure for healthy black men, like the ones in this study who took calcium. And mu sub P, same thing, true population mean decrease in systolic blood pressure for healthy black men, like the ones in this study who took a placebo. Okay, so we're going to run through this phantoms process. We just did the P in phantoms where we define the parameter of interest. Now we're going to move down to the H in phantoms. We're going to state the hypothesis and the significance level. Remember, the null hypothesis is always a statement of equality. What we are looking for is there evidence that the calcium supplement reduces the blood pressure more than the placebo? Okay, so I want a larger number. A larger number means more reduction. Okay, more reduction. More than the average of the placebo. And our alpha level, our sig level is 0.05. If they don't state that, this is kind of our default alpha level. Okay, the A for assumptions is where we run through our conditions. We want to definitely say, now remember, in terms of randomness, these individuals were not randomly selected. I underlined here that they were volunteers. Okay, so the random piece is met by mentioning that the treatments were randomly assigned. So we want to say treatments were randomly assigned. Now, if it's an experiment, you don't need to say anything about independence. Okay, because we never selected these people randomly or independently. Okay, also, when it is an experiment, you don't need to do anything with the 10% condition. Okay, that also has to do with independence, and we don't need to worry about that. We only have to say that the treatments were randomly assigned, and then we have to check off the normality condition, which again, you'll notice there was no mention of a population being normal. Our sample sizes were only 10 and 11 for our two treatment groups. That's not central limit theorem. You would have to take all of the data that you see for group 1 and put that in L1. All the data you see for the placebo group goes in L2. You would need to construct box and whisker plots for each of those. You can see I already did this here for you. Has to be copied down on your paper. Have to label what the x-axis is. This is the mean decrease in systolic blood pressure, and you need to identify which box and whisker plot comes from which treatment group. Okay, now, the part that I am missing, I did say no extreme skewness or outliers. I should then say I'm going to use the symbol here with the 3 dots, which means therefore, my conclusion is this is approximately normal. Okay, I'm moving down to the end, the name the inference procedure that will be used. The inference procedure is this is a 2-sample t-test for means. Okay, then we're going to move to the calculator portion. The T is where we're going to use our calculator to find the test statistic. This is the T-score that I'm ultimately wanting to report here. You should be selecting on your calculator screen the 2-sample t-test and make sure that you are recording all the calculator inputs. Okay, when you select this, the 2-sample t-test, it's option 4 on my calculator. You're going to want to make sure that you're selecting the input option as the data option, because you can see in this problem, they have not given you the statistics. We don't know the mean, the standard deviation. We have the set of data that you already should have in L1 and L2 from having made the box and whisker plots from this normality condition anyhow. Okay, you want to go on down through, make sure you select no to the pooled option. And you're going to press enter, and you want to report all the values that you are given here. Okay. Now, again, this is all referring to my calcium group, and this is all my placebo group. And you're going to report the mean and the standard deviation for each of these sets here. Okay. Just writing down the numbers that you're seeing on the screen. Okay, and the degrees of freedom, 15.59. Okay, here is my t-score here. Okay, you'll notice in this box over here, I went ahead and showed the formula, and I went ahead and plugged the values in. If you were going to do this using the formula, again, it's not something that I would advise. I would just advise doing this on the calculator. Okay, the other thing you're going to be seeing on your screen is the p-value, and that's what we're going to record down here for the O step. The p-value, 0.0644. Okay, the m, this is where we're going to make a decision. We're going to say since the p-value of 0.0644 is actually greater than our alpha level of 0.05, that is when our conclusion should be that we fail to reject the null hypothesis. Okay, so this means that we do not have convincing evidence that, okay, remember what you put after your statement of either having or not having convincing evidence is always whatever your alternative hypothesis was referencing. So if you look back up at the problem and just kind of say this in words, that the true mean decrease in blood pressure for the calcium group is greater than the true mean decrease in blood pressure for the placebo group. Okay, that's what we want to say in words, our alternative hypothesis, that the true mean decrease in blood pressure for the calcium group is greater than the true mean decrease in blood pressure. It's a lot of writing, I know, for the placebo group. I probably should say, since these were volunteers, for men like those in this study. I should not say for all black men. I should just say for men like those in this study because they volunteered to participate and were not selected randomly. Okay, the last part, which is really important, they are asking us to interpret this p-value that we got up above here. Okay, what does that p-value mean? Well, that p-value always is assuming that the null hypothesis was true. So assuming the null hypothesis, which is that these two means were actually equal to each other, is true, then there is a 6.44% chance of getting a difference in mean blood pressure reduction for the two groups, calcium minus placebo, of blank or greater. Now, what is that difference? Well, let's look up here and see. We had the calcium mean to be 5, the placebo mean to be negative 0.27. So if I do the difference between those two sample means, I end up getting 5.27. There is a 6.44% chance that if we were to do this again, the difference we would get in our two sample means would be 5.27 or larger. I know there's a lot of steps. These problems are really big. Here are a few problems for you to try.